Disadvantages of stop and copy. Twice as much memory is needed for a given amount of heap space. Objects are moved in memory during garbage collection. References need to be updated. The program must be halted while garbage collection is being performed. Availability of garbage collector in programming languages. Generally speaking, higher level programming languages are more likely to have garbage collection as a standard feature. In languages that do not have built-in garbage collection, it can often be added through a library, as with the Bohem garbage collector for C and C++. This approach is not without drawbacks, such as change in object creation and destruction mechanisms. Most functional programming languages, such as ML, Haskell, and APL, have garbage collection built in. Lisp, which introduced functional programming, is specially notable for introducing this mechanism. Other dynamic languages, such as Ruby, also tend to use garbage collector. Object-oriented programming languages such as Smalltalk, Java, and ECMAScript usually provide integrated garbage collection. A notable exception is C++, which uniquely has destructors. Historically, languages intended for beginners, such as BASIC and Logo, have often used garbage collection for variable length data types, such as strings and lists, so as not to burden programmers with manual memory management. On early microcomputers, which they are limited memory and slow processors, basic garbage collection could often cause apparently random, inexplicable pauses in the midst of program operation. Garbage collection in C. The programming language is ideally suited for embedded systems. It provides low-level control, portability, as well as structured programming. It does not provide native garbage collection. The lack of a garbage collector could be considered a limitation of C. However, it is possible to implement a trivial garbage collector if we are willing to live with a few limitations. Garbage collection in C++. A garbage collector is handy since it eliminates a big source for bugs, runtime crashes, and memory leaks. However, garbage collection is not for free. It incurs additional runtime overhead for repeated operations like compaction, reference counting, and memory initialization. Furthermore, when you use garbage collection, destructors are not necessarily invoked right after an object is destroyed, but at an indeterminate time afterwards. For these reasons, C++ does not provide a garbage collector. Nonetheless, there are techniques to minimize and even eliminate the perils and drudgery from manual memory management without the associated disadvantages of garbage collection. Garbage collection in C#. A significant advantages of C# when compared to C++ is the memory management capabilities of the C#. The programmer need not worry about memory management. The garbage collector is assigned this operation on the programmer's behalf. You will probably know that value data types are stored on the stack while reference data types are stored on the managed heap. The stack stores data value type that are not members of objects. Also in C#, it is always the case that if variables goes into scope before variable B, then B will go out of scope first. For example, if you declare some variables in a method, these variables will go out of scope when the method ends. However, it may be sometimes that you need to keep these variables long after the method function ended. This happens for all data declared with the new operator, the reference types. All reference types are stored in the managed heap, which is under the control of garbage collector.